Is everybody aware that low classes? I think we are meeting after a very long gap. So you have to tell me क्या कर रहे थे? Last lecture में क्या किया था? Sound start हो गया था? Spectrum. Sound चालू कर दिया तो मुझे लग रहा है ना? Spectrum खत्म हो गया था बेटा. Did you attend the last lecture? Sound start कर दिया था. Okay. And parallelly Sunday को भी तुम्हारा कोई lecture हुआ रहेगा ना अभी? Sunday को एक lecture हुआ है तुम्हारा? आशुतोष सर ने लिया होगा? नहीं, अभी तक नहीं लिया. हाँ, मतलब नए सर नहीं है, केमिस्ट्री के लिए नहीं. नहीं, तुम लोग को क्या, हम लोग को नवंबर तक पोर्शन खत्म करना है ऐसा बोला है, क्योंकि तुम्हारा प्री बोर्ड स्टार्ट हो जाएगा. तो 4 घंटे महीने में होते हैं तो उससे नहीं खत्म हो पाएगा. इसके लिए हम लोग ने क्या किया है, और एक सर को 2 टॉपिक दिया है. आई थिंक इलेक्ट्रोमैग्नेटिक इंडक्शन एंड हीट. जो लास्ट 2 टॉपिक है ना, संडे को होगा. वो पता नहीं शुरू हुआ है कि नहीं तुम्हारा. शुरू हुआ है ना, संडे को हुआ है ना.
2 घंटे का लेक्चर था, बट
2 नहीं 3 घंटे का. फिजिक्स का हुआ क्या? फिजिक्स का नहीं हुआ क्या? अच्छा, ओके. साउंड में कहाँ तक किया था हमने? We just started, I think. Did we differentiate between light and sound waves? Okay. So next topic is reflection of sound waves. यहाँ पे मैं रखता हूँ. Are you audible to online students?
Yes, sir. Yeah.
Okay. Next topic is reflection of sound waves. So all waves undergo this phenomenon, reflection and refraction. Okay? If it is a wave, it can be reflected. So obviously it will obey laws of reflection, which is angle of incidence is equal to angle of reflection. So if this is an obstacle, right? So if this is the normal, so any sound wave is incident in this direction, then it will be reflected on the other direction like this. Okay? So this law is obeyed. So this is some obstacle. Obstacle or reflector. Only condition is the size of the obstacle should be comparable to the wavelength of sound wave. Okay? Case of sound wave. The size of the obstacle should be comparable. The wavelength of yes. Okay. So in comparison to light wave, the obstacle size would be bigger. Optical in this case could be what? The reflector could be like, example, wall. It could be wall of a building. Okay, or hill. or edge of forest. ठीक है, बड़ा रिफ्लेक्टर होना चाहिए तो ये साउंड वेव रिफ्लेक्ट करेगी. So what if the sound wave is traveling along the normal? ऐसे जा रहा है. Sound is incident along the normal. Then it will reflect. ठीक है, it will retrace the original path. So one of the application of reflection of sound wave is echo. Application of reflection of sound wave. Echo. Okay, so we'll now cover this thing in detail. What is echo? And there are some numericals for this. Can I erase the left side?
Yes.
Yes, sir. So let's write down conditions for first of all, what is echo? What is echo? Anybody? So reflection, first of all, you understand what is reflection, right? What is reflection? So bouncing back of sound wave in the same medium, okay, by the obstacle. That is the reflection of sound wave. So the reflection of sound wave is bouncing back from the by the obstacle. Obstacle is the reflector. In same medium. In same medium, in accordance with laws of reflection. In accordance. Can you see the board, everybody? In accordance with laws of reflection. Okay, so that is reflection of sound, and echo is one of the application of reflection of sound. So what is an echo, or have you heard echo? So how do you put it in words?
Echo sound. Word after.
So it is the sound heard after the original sound ceases to exist. There are two distinct sounds: the original sound and then the reflected sound. Okay? So you hear echo only when the original sound has died out. Okay? So echo is produced when a distinct sound is heard. The original sound ceases to exist. After the original sound ceases. So during echo, distinct sounds are heard. Where it is the spelling correct? HEARED or just something is correct. Okay. So two distinct sounds are. Okay. So why are we not hearing echo in this phone? Closely. Walls are close. So they are not satisfying the condition, right? Not every wall will reflect sound and will hear echo. Why? Whenever I'm speaking, okay, so that is the original sound. That original sound I also hear. Whatever I'm speaking, I also hear. And that remains in the ear for 1/10 of the second. 1/10 seconds, it remains. That is called persistence of sound. Okay. So to be able to hear the echo of my own voice, I should hear the reflected sound after 0.1 second. So after 0.1 second के लिए, the sound should go till the obstacle and come back. And that duration should be more than 0.1 second. And what is the speed with which sound is traveling? 340 at ordinary temperature, 340 meter per second. So it is traveling really very fast. In a second, it is going 340 meters. Okay, so that fast. So by this wall, it is almost instantaneously reflected back. Okay. So let's understand what is the conditions for echo. For echo. So first is minimum distance of the obstacle should be at least 17 meters. Okay, so let's calculate it. Let us say here is the source of sound and this is a reflector or a wall. So when he speaks, and let's say this distance is d. When he speaks, it goes to the wall and then the reflected sound comes back. Right? So the speed of sound is given as how much distance is traveled, d while going and d while coming back. So it is d plus d divided by whatever is the time duration. Okay. So this gives us 2d by t. So what do we get? We get d is equal to therefore dt on 2. And what is the speed of sound? 340. T should be at least 0.1 second. So beyond that, we should be able to hear the echo. So what is it? 34 by 2, which is 17. So the obstacle should be minimum 17 meters away for us to be able to hear the echo. Yes.
Nothing is there, only voice. No permission is there. Then also the voice.
That is reverberation, not echo. Echo में दो ही sound हो. It is prolonged, so it's multiple reflection. ठीक है? तो वो कैसा होता है? कुछ बोलो तो it stays there for some time. छोटे रूम में तो नहीं होता है. बड़े रूम में हो. At least 17 feet to satisfy होना चाहिए. ठीक है? तुम वो हमिंग साउंड होता है, इट्स नॉट टू डिस्टिंक्ट साउंड. ठीक है, तो वो कैसे हो जाता है? व्हेन यू पुट फर्नीचर्स, कर्टेन एक्सेट्रा तो एब्जॉर्ब कर लेते. दोस आर नॉट टू क्लियर साउंड, जस्ट ऑब्जर्व इट अगेन. वेयर विल यू हियर इको? व्हेन यू गो टू अ एम्प्टी ऑडिटोरियम. ऑडिटोरियम होना चाहिए तो फिर सुनाई देगा, बट वो एम्प्टी होना चाहिए. ऑडिटोरियम में भी सब कर्टेन लगा हुआ है, यहाँ पे देखोगे सब सॉफ्ट बोर्ड्स रहता है, सीमेंट वॉल नहीं रहता है. क्या रहता है? गत्ता होता है. हाँ, मतलब एब्जॉर्बिंग मटेरियल, साउंड एब्जॉर्बिंग मटेरियल है. जैसे सिनेमा हॉल में जाओ ना, क्या रहता है? इट्स नॉट अ सीमेंट वॉल, इट्स वुडन और some sound absorbing materials are placed. और कपड़े लगे रहते हैं ना, वेलवेट टाइप के, या so that is to basically not reflect the sound. What is the second condition? Second condition is the speaker should produce sound with enough intensity so that it can go there and come back, right? Otherwise वो medium में absorb हो जाएगा. So it should have enough energy. So what is intensity? Energy flowing per unit area per unit time. So that's intensity. The sound should have the source of should produce sound with adequate intensity. Or the reflected reach back. The source of sound should produce sound with adequate intensity for the reflected sound wave to reach back the observer, for the echo to be heard. Again, that's point number 2. Next. और क्या? और एक है ना?
Size of the reflector must be large.
Yes. Size of the reflector should be comparable to the wavelength of the sound. What is the wavelength of the sound? Almost 10 meter, between 10 millimeter to 10 meter. तो higher side पे 10 meter लेके चल सकते. ठीक है? The wavelength, the size of the obstacle or reflector of the sound is large enough. It is comparable to length of sound. It's nearly 10 meter. Minimum 10 होना चाहिए, उससे बड़ा होगा तो चलेगा. Actually the range is 10 millimeter to 10 meter. तो higher side में रखो. ठीक है, so any questions on echo? So next topic is determination of sound wave by method of okay. So determination of sound wave speed by method of echo. So we can use the same formula, right? So what can be done is, suppose the observer is standing from the reflector at a known distance. So D is known here. So when he produces the sound, that time he presses the stopwatch. And when he hears the echo, that time he stops it. So here's the time. So he notes down T by stopwatch. So he records time on stopwatch. So then what is speed of sound? Therefore, V is equal to D by T. So experimentally, this is how velocity of sound can be calculated. So stand in front of the obstacle, shout out loud, and start the stop clock. When you hear the echo, stop it. So you have time and you know how far is the obstacle. 2 times the obstacle distance divided by hazard time. That gives speed. And you will get it at ordinary temperature. You should get it at 340. Okay. So this is how we can calculate speed of sound. With this, we come to the last part of first unit, which is, can I raise left side? Udays of echo. Ready?
Yeah.
The uses of echo, there are primarily 2 uses of echo. First is called sound ranging. Okay. What is the meaning of sound ranging? To estimate the distance of obstacle. Okay. So this is basically, that is estimation of distance of obstacle. This obstacle could be enemy or it could be prey or target. Okay. So how far is the enemy or target or obstacle? Like if the ship is navigating through the sea, so there are some icebergs which are under the water. So if ships continue to go through that, so it may get damaged after it collides with the iceberg.
वो तो सोनार का यूज कर रहा है सोनार का
वही तो सोनार है. Sonar works on echo, right? What is sonar?
इधर दो सब है ये दो है
वही तो, इसलिए तो वो सब खिचड़ी है आगे पीछे करके. So we'll follow this. ठीक है. So main thing that sonar, what it does is sound ranging. That is sonar, sound, navigation and ranging. Okay. So next is echo depth sounding. Now this is not different than this. Same thing. खाली अलग अलग टर्म देके कंफ्यूज किया. यहाँ पे भी you are now estimating the depth, which is again distance only, but it is vertical distance. How deep? ठीक है. But then you call it echo depth sounding. हाँ, पानी में या फिर see ultimately it is sound ranging only. ठीक है. So basically what you do is, what kind of sound wave we use in this? Ultrasound. So how we do this is by sending ultrasound waves. Is ultrasound wave audible to humans? No, we cannot, right? So this is out of audible limit. So ultrasound is different, outside audible limit, outside. Audible range of humans. ठीक है. So echo depth sounding is basically calculate the depth of sea, river, etc. ठीक है. So these are two major applications. Basically, it is one application only, but put different. Okay. Let us now learn the applications of uses of it. Let's see how it is used by animals. Then we'll see how man uses it. Okay. Why? Why whom? Bats and dolphins. Again, bat, dolphins, dogs, rats, some fishes, right? They can produce and detect ultrasound waves. Okay. So let us say you have a bat. Okay. Bat जैसा दिख रहा है. So this bat is, let us say, producing sound wave ऐसे. ठीक है. They cannot see. Bats cannot see. So what do they do is they produce ultrasound waves, and it then goes in all directions, right? Everywhere it goes. It goes in all directions. So let's say you have some obstacle here. Obstacle in terms of the wall or tree, stem, right? So from the echo, it will come to know that this is not the safe zone to fly. It will navigate in a different direction. Okay? So that's how bats can navigate. Likewise, dolphin. Dolphin कैसे होता है? तो dolphin का भी यही सीन है. ये क्या करता है? They also produce ultrasound waves, send in all directions. ठीक है? So wherever they sense threat, तो वहां से direction change करके और चला जाए. And from the nature of the reflected wave, they can also figure out whether it is a soft target for them to go and grab it. ठीक है? So it could be target as well as obstacle. So that is the application by animals. Dogs also are capable of hearing ultrasound waves.
Next patient
हाँ? Yes. तो वो basal उनको नहीं सुनाई देगा, dogs को सुनाई देगा, ठीक है? So that is the application of echo by animals. Now we as man, basically fishing community, right? Fishermen, right? So let's say they have taken their fishing trawler deep sea somewhere, right? So they have a instrument. Now these animals can produce ultrasound waves themselves, right? But we as humans, we have an instrument which has transmitter and receiver set of ultraviolet waves. So it will send in every direction. Okay? Let us say you have a fish constellation here. Okay? So it's called shoal of fish. Okay? So कहाँ से इसको जो echo receive होगा, and by the analysis of that received echo, they will come to know that there is a group of fish available. They will just position there and drop their net and fish them out. So that is the application of echo by fishermen. ठीक है? Same ही है. So now sonar. So he is stuck on sonar. Why are you stuck on sonar? Sonar is just the technical name for sound navigation and ranging. What you have to understand is navigation is this. When he senses the obstacle here, changes the direction. Like ship sensing iceberg, changes the direction. That is navigation part of it. Ranging is how far is that? Estimation of distance. That is ranging. Okay. Then we have something called as radar. What do we do in radar? Ranging. Radar is radio, navigation and ranging. That is radar. So what's the difference between sonar and radar? Which will be fast? Radar or sonar? Radar. So radar is used for military applications or critical applications. Okay? Or airplane communication will be based on radar. But if it is ship, sonar is sufficient. Speed is less for ship as compared to aeroplane. So in war situation, military situation, we need fast feedback. So what's the difference in speed? Radar, radio wave, right? Travels at 3 to 10 raised to 8 meters per second. What about ultrasound wave? See the difference in scale, right? So there is huge difference. So obviously these equipments will be much costlier. Okay, and this will be relatively cheaper. Okay, so no question is expected on radar. Maybe what's the difference between sonar and radar? They might ask. Only difference is radar uses radio waves for communication. Sonar uses sound waves, and in sound wave, ultrasound. Okay, what's the gadget? The gadget has, like our mobile, it has both transmitter and receiver. Likewise, you have it is called sound vibrator. Or you can call it transmitter receiver set. Trans receiver. मैं बुक कहाँ रखूँगा फिर? मेरा बुक लेके बैठेंगे? यहाँ बैठेगा ना सेकंड में? इधर आ जाओ. ठीक है? So this is either sound vibrator or trans receiver set. So you get trans receiver set for sonar, for radar. Okay. So it depends. What is the machinery inside? What kind of wave is capable to produce? Okay. So Shall we go a little deeper? So we have understood about application of echo by bat, dolphin and fisherman folks. There are some medical applications as well. So second is use of sonar. Okay, that's the second application. So this is nothing different. Sonar is also used for estimation of distances. वही चीज तुम echo set down, echo depth sounding में भी करोगे. ठीक है? So that should be clear now. What will be used for echo depth sounding? For echo depth sounding, we will use sonar, which is this setup. In any direction you can send. So if you send it vertically down, that's when you can measure depth. How will you measure depth?
Calculate
D is equal to 2D by T. So D is equal to VT by 2. So D. So what you will note down is time. The velocity of the ultrasound wave in water is known to you in sea. It is 1400 meter per second. So velocity of sound is different in different mediums. That is already known. So V is known. T you can measure. T is the time between the transmitted wave and the reflected wave जब receive करते हैं वो वाला. तो D तुम्हारा निकल जाएगा. VT by 2. So in this chapter only one formula. D is equal to 2D by T. Put differently, D is equal to VT by 2. Okay. All right. Then the last application of echo is medical application. Medical application. So first is ultrasonography. So ultrasonography, sonography में ultrasound wave use करेंगे तो ultrasonography. Doing sonography using ultrasound waves. Okay. Sonography कर ले यार. Sonography. Using ultrasound waves. Then what do we call it? Ultrasound. Point is ये तो term हो गया. अब इसको किसके लिए यूज करते हैं? Detecting kidney stones. हाँ? Detecting kidney stones. Kidney stone या फिर do the imaging of internal organs. Do the imaging of internal organs. Check the status of babies. क्या बोलते हैं? Fetus. क्या बोलते हैं? Fetus. Check of FOET. ये क्या? Fetus. ठीक है, ये कर सकते हो. So imaging में क्या करते हैं कि ultrasound waves are sent and then from the reflected ultrasound waves they are then fed to computer. Okay, so the sound wave is converted into electrical. Sound is energy. One form of energy can be converted into other form of energy. So from the converted electrical signals, when it is processed, then there is a technique to develop it as an image. Okay, so you can figure बगैर cut किए you can see what is going on inside. Plus it is safe. Sound wave is safer than electromagnetic waves, isn't it? So since we are dealing with live beings, so it is safe to use ultrasound waves. X-ray वगैरह डालेंगे तो फिर खत्म ही हो जाएगा वो, है ना? एनर्जी बहुत ज़्यादा है. So this is safer technique. What else? When we use sonography, internal organs में क्या हो गया? देखो gall bladder हो गया,
See the image of heart, we use cardiogram.
Gall bladder और क्या है? Liver, ठीक है, etc. If you are doing imaging of heart, then it is called echocardiography, right? Is it echocardiography?
Yes.
Is that the word?
Yes.
So echocardiograms. So doctor is handicapped unless the physicist provides them or equips them with some instrument. So you can't figure out what's going on, right? So echocardiography used for imaging of heart using ultrasound waves. Right? Already weak heart, जिसको तुम अगला वाला इलेक्ट्रोमैग्नेटिक वेव यूज करो, देखते देखते चलाए, ठीक है? तो ये हो गया तुम्हारा मेडिकल एप्लीकेशन. और कुछ बचा है क्या? It can also be used to break kidney stones and all. ठीक है, लेकिन वो उसमें नहीं दिया हुआ. हाँ, इससे भी कर सकते हैं अल्ट्रासाउंड से, मतलब वो भी एनर्जेटिक है. लेजर्स यूज करते हैं आई सर्जरी और इसके लिए. आई थिंक यू कैन डू अल्ट्रासाउंड आल्सो, इफ आई एम नॉट रॉन्ग. All right, so we are almost done with where is the class ending? फिर से आ रहा है. ठीक है, तो न्यूमेरिकल तो हमारा खत्म हो जाएगा. अब डी और नेक्स्ट क्लास. How many numericals in this? 12. Odd, even? All. Okay, one I do, one you do. ठीक है, चलो. Let's start with first. So in my book, the numericals and values may be different. So I would ask one of you to read it. What is the first numerical?
The wavelength of waves produced on the surface of water is 20 centimeters. The wave velocity is 24 meters per second. Calculate the number of waves produced in 1 second.
Okay.
Time in which one wave is produced.
Okay. So this is same. My book. So, given. What is given? Lambda. 20 centimeter. Velocity is given as 24 meter per second. So you have to find number of waves produced in 1 second, means you have to find frequency. Waves per second is frequency. The second you have to find the time in which one wave is produced is time period. Time for one wave is called time period. Okay, this is what it means. So you can do it now. So what is the relation between so since V is equal to F lambda, is the relation applicable to all waves, irrespective of what type of wave it is. Okay, so find F. So therefore, this is the main relation. Therefore, F is equal to V by lambda. So what is 20 centimeters? 0.2 meter. What will you get? P is 24 divided by 240 by 2. 120 hertz. Or 120 per second. So it will be therefore 120 waves in 1 second. What is the meaning of frequency? How many cycles per second? So 120 waves in 1 second. So what do you say? Second. Hertz is also written as per second or per second. Next. Time period क्या होता है?
1/n.
Yes. Time is reciprocal of frequency. 1 by 120. How much is 1 by 120? One by 120 कितना आ रहा है?
3.8 will be about minus.
निकाल लिया इतनी इजली?
हाँ. दोनों को multiply by
Multiply by
value multiply and divide by physical quantity की value लानी.
कैसे? 1000
about 120 1000. फिर 1000 और 120 को करेंगे
divided by 12 ऐसे.
ये हो गया 8.3.
50 by 6 तो 10 to minus 3 तो ही है.
हाँ तो 8
6 से जा 48.
3 are 8. Okay. Count of 4.
चलो ठीक है. ओके, ये हो गया तुम्हारा फर्स्ट क्वेश्चन. सेकंड वाला तुम लोग करो. जिसमें क्या इक्वल का क्वेश्चन है? Yes. So B is equal to B into T by 2y. Speed of sound 350 लिया है. T 0.1 ले लो. तो 35 by 2. 17.5. तो हर जगह पे इको के केस में टी यू कैन टेक एज 0.1. यहाँ पे भी वही है. टी इज इक्वल यहाँ पे कितना दिया बी? है. T निकालना है. T is equal to 3 by B. So क्या लिखा है? 2D upon P is equal to 2 into D. D लिखे यार. D 35. D क्या है? 358. Also. What by 6 now? Now the 1 by 6 second. आ रहा है क्या 0.143? So will the man be able to hear distinct echo? Yes, because it is greater than 0.1. The answer is yes. Since E is greater than 0.1. ये तुम्हारे स्कूल में हो गया साउंड? क्या चल रहा है स्कूल में अभी? कौन सा चल रहा है चैप्टर अभी? ठीक है, so we are ahead, so that's fine. Question 5, what is the question? Radar वाला है क्या? Yes. यहाँ पे भी T is equal to 2D by P आ जाएगा. T कितना दिया हुआ है? 45 किलोमीटर. देखो रडार का क्वेश्चन आ गया. रडार के क्वेश्चन में स्पीड रडार का लेना पड़ेगा, मतलब इलेक्ट्रोमैग्नेटिक वेव का लेना पड़ेगा. ठीक है, रेडियो वेव, और ये 45 किलोमीटर है. अभी तक देखो साउंड वेव में कैसे डिस्टेंस थे 70 मीटर, रडार में कैसा डिस्टेंस आ गया 45 किलोमीटर. ठीक है, ये सब है. तो 315 15 टू जो कितना हो गया 30 minus 8 कितना होता है 1 2 3 4. इसको तुम 30 मिली सेकेंड भी लिख सकते हो. 3 into 10 is to minus 4 seconds. अपने बुक में देख लेना न्यूमेरिकल सेम है कि नहीं, अदरवाइज साउंड क्या हो. डिफरेंट है ना. क्या है क्वेश्चन, क्या है डिस्टेंस 300, तो 300 ले लो. मेरे बुक में 45, बाकी सब सेम है. और इजी कर दिया. 300 तो ये क्या हो जाएगा 100. 200 into 10 raised to कितना है तुम्हारा 2 into 10 raised to minus 6 2 माइक्रोसेकंड. तो न्यू बुक में डेटा अलग है, मेरे बुक में 45. जिसके पास ओल्ड बुक है उसमें 45 किलोमीटर दिया होगा. न्यू बुक में कितना है 300 किलोमीटर के. ठीक है, तो ये आंसर ठीक है, नेचुरल है. 300 किलोमीटर 300 किलोमीटर ना. हाँ, तो into 1000. तो अभी ठीक है 2 into -3. ठीक है, ये तो -8 होगा. ठीक है, 2 मिली सेकेंड. अभी ठीक है. हाँ ठीक है 2 into 10⁻⁻3 चलो 6th वाला तो क्या क्वेश्चन है 6th वाला ठीक है I hope the data is same here. Man standing 48 meter away. क्या दिया है? D is equal to 48 and fires a gun. Calculate the time after which the echo is heard. D is equal to 320. The time is distance upon velocity. सब वही एक ही फॉर्मूले का क्वेश्चन है कितना है हमारा आंसर 0. ओके सेकंड नेक्स्ट करते जाओ क्वेश्चन तुम लोग सारा जो नहीं हो रहा वो मेरे को बोलो फॉर्मूला एक ही है इसका Speed of sound in water is 1450 meter per second. The question is ठीक है सेम ही क्वेश्चन 7 बन गया सबका ठीक नेक्स्ट कोई है जिसको 7 नहीं आया ठीक है 7 सभी का हो गया 8 ट्राई करो सब लोग 8 बन गया 8 तो मजा आएगा 8 हो गया 8 वाला जिसका हुआ किसका है पेंडुलम है तो हो गया 8 वेरी गुड ठीक है 8 का मैंने क्लू दिया है टाइम इसमें नंबर ऑफ वाइब्रेशंस के हिसाब से दिया है 1 सेकंड में 5 वाइब्रेशन हुआ एक वाइब्रेशन का टाइम कितना हुआ 1/5 सेकंड 8 वाइब्रेशन कितना होगा 8 into 1/5 पीरियड निकाल दो एक वाइब्रेशन का टाइम क्या टाइम पीरियड 1/f ठीक है सो 1 और 8 वाइब्रेशन के बाद उसको इको सुनाई दे रहा है तो कितने टाइम के बाद सुनाई दे रहा है 8 into 1/5 ठीक है 8 हो गया Period के बाद leaving my book here. It is very important.
Sorry.